Okay, so hi everyone, welcome at this STORK Journal Club where Professor Aina Chalabaev will present a paper named Falsificationist Treatment of Auxiliary Hypotheses in Social and Behavioral Sciences. Professor Aina Chalabaev is a professor in sports science at the University of Grenoble, and she's working on barriers to physical activity such as stigma or health behavior change in general. So she will discuss this paper that we worked on a recent paper we wrote, and that discuss falsification and auxiliary hypothesis in social and behavioral science. So Aina, it's whenever you want. So you will have a 10-minute time presentation with some slides that summary the paper, and then we will discuss the article.
Yeah, actually, I have included some questions inside the slides. Maybe I won't speak 10 minutes and then discussion, but the discussion will be inside the slides if it's okay for you.
Okay, perfect.
Okay, so first of all, I would like to thank very much STORK and more particularly Cyril Forestier for the invitation to lead this journal club. And I am very pleased to talk about an article that has been printed on Psych Archive by Duygu Uygun Tunç from Middle East Technical University in Ankara, and Mehmet Nesip Tunç from Tilburg University. I hope my pronunciation is okay. I think this is an important article that proposes a method called the systematic replications framework, which is supposed to address the problem of underdetermination in social and behavioral sciences. The problem of underdetermination arises when alternative explanations of results exist, which make interpretations difficult to make, and it's a problem particularly present in social and behavioral sciences. So this is the starting point of the article, and before this method, I would like to define some key concepts and the approach on which the article is founded, so that we can better understand the method proposed. Of course, do not hesitate to interrupt me during the presentation at any point. I will try to be as pedagogical as possible, but don't hesitate to interrupt me. So the first concept I would like to introduce here is the concept of falsification, as introduced by Karl Popper. Popper's aim was to find a criterion able to demarcate science from non-science. And to do so, he proposed the falsifiability criterion, according to which a theory is scientific only if it is possible in principle to establish that it is false. So for Popper, this means that scientists should attempt to disprove their theories rather than attempting to prove them. He considers that no matter how many confirming instances there are for a given theory, it only takes one disconfirming observation to falsify it. So in other words, scientists are never finally confirmed because disconfirming observations are always possible. And this approach, falsification, is crucial because science progresses when a theory is shown to be wrong and is replaced by a new theory that better explains the phenomenon of interest. So in this approach...
May I just ask you something, Aina? There is a comment that say that sometimes you are breaking and freezing a little bit, and so there is kind of a lag between what you say and the image. So maybe you can shut down your camera and try with just your voice. Maybe it will be better.
Okay, sorry about that.
Maybe you can just try it. Sorry to interrupt.
Yeah. Okay, I'm sorry about that and hope it will be better. So in this approach, it is fundamental to give the possibility for theories to be falsifiable, and this can be done by deriving empirical predictions from theory and search for the instances that can potentially contradict these predictions. Okay. Another key concept that needs to be introduced here is the concept of auxiliary hypothesis. So, as we said in Popper's approach, theoretical propositions need to be empirically tested. And this to be possible, needs to be bridges that link abstract concepts to their empirical instances. And these bridges are called auxiliary hypotheses and correspond to assumptions regarding the nature of abstract theoretical constructs. More particularly, auxiliary hypotheses range from various assumptions regarding the quality research design elements, including the statistical analysis strategy, the quality of the experimental conditions, the reliability of the measures, or the validity of operationalizations. And one issue, especially in social and behavioral sciences, is that there may be uncertainty associated with these background assumptions. For example, we may not be sure that our operationalizations of reflect the true concept, or that the experimental conditions correctly manipulate the concept. And this issue is particularly important when we take into account what has been called the Quinn thesis, which poses that theories do not logically imply testable predictions, because on the one hand, theoretical terms are not directly observable, and theoretical terms and their empirical instances are not directly linked. What does this mean? It means that scientific theories have empirical consequences only in conjunction with auxiliary hypotheses. And in other words, it means that a theoretical hypothesis cannot be tested in isolation. So this creates ambiguity in the falsification principle, and the paper of Tunc and Tunc propose to visualize this problem as follows. So, okay, so here we have a theoretical hypothesis in which X predicts Y, and this hypothesis is empirically tested by operationalizing the X and Y concepts and by testing the relationships in a dedicated design. And so, as we said, auxiliary hypotheses are the background assumptions that allow to bridge theory to empirical test. And the problem is that when we test a theoretical hypothesis, we, in fact, test three hypotheses simultaneously. Theoretical hypothesis, but also the auxiliary hypotheses that are related to making X observable and Y observable. And the consequence is important because when test results refute an hypothesis, then we don't really know whether it is a theoretical hypothesis that is refuted, or if it is an auxiliary hypothesis associated to X or to Y. So this is called the ambiguity of falsification. Okay. So I'm going to give an example in sports sciences, in exercise psychology more particularly. So for example, if we want to test whether social presence predicts basketball performance, we need an auxiliary hypothesis that links the theoretical predictor to the observable predictor. Mental manipulation of audience. And we need another auxiliary hypothesis that links the theoretical outcome, basketball performance, to the observable outcome, for example, the number of successful free throws. Okay, so this means that for every single empirical test, we pose at least, for example, if we want to test the effect of social presence on basketball performance, we pose at least 3 questions. Does social presence predict basketball performance? Does experimentally manipulating social presence measure social presence? And does the number of successful free throw capture basketball performance? And I think that you would agree that answering the questions associated with these oxidized hypotheses is not simple. Free throw task may not perfectly capture basketball performance, and depending on how the presence of audience is manipulated, this may not perfectly reflect the abstract concept of social presence. Okay, so before going any further and developing the proposition of Tunc and Tunc, I would like to ask you and to know if you have any ideas about how can this ambiguity of falsification be addressed. And if anyone has any ideas, for example, do you think that if we use reliable and valid measures and design, can it help to address and to limit this ambiguity of falsification? Do you have any thoughts about that?
I think
yes, there is one thing. Sorry, Amy. There is one thing that I like in what you just wrote, Aina, is that you wrote measures and designs, and so yes, I think if we are using valid and reliable measures for different for a same abstract construct, it could be one of the way to resolve the ambiguity of falsification.
I think that I 100% agree. Yeah, valid and reliable measures and designs are obviously huge. I think the tricky bit though is sometimes we just have to work with what's available. Like, for example, in terms of I work in bone metabolism, the biomarkers are tricky, but they're the best we've got. So sometimes it kind of feels like we have to work with the information that we have and just deal with the uncertainty that's there, because I sometimes feel if we pull too hard at these threads, we'll never do anything. And certain constructs are, I suppose this is where I really struggle, is like you've got a construct or you've got something that you want to measure, and then you've got an outcome that represents that. How close is close enough? Because it's never going to be an exact representation. And that's something I really struggle with.
Okay, any other thoughts?
Yes, I just have another idea, but regarding it's maybe just more a comment, but as you say, when we are doing a statistical test, we are trying to conclude that there is an effect, and we are often not trying to highlight that there is no effect. So we are not trying to falsify, but we are trying to confirm that something is happening. And so maybe the use of the more regular use, like it's actually discussed, of statistics that could detect an absence of effect that could falsify. It doesn't work. There is absolutely no effect of, or not a meaningful effect of what you try to manipulate on what you are interested on. Maybe it could be another way to improve the falsification process. I don't know if it was rather clear or not. Maybe Aaron can explain this better than me.
Yeah, I think I understand what you're saying, your point. But I'm wondering if, I mean, when we test our hypothesis, in fact, I think that we are implication principles in the sense that when we interpret our results, we are not confirming our hypothesis, but we are trying either to reject the null hypothesis and or not reject it. And so the fact that we make the focus on rejecting or not the null hypothesis, I wonder if it's not in line with the falsification principle. Mm-hmm. Although I agree with that, we tend to forget that that the focus is on the null hypothesis.
Yes, but yes, this was my. I think what you said is absolutely correct. But what we often plan is how will we accept that there is an effect, and we never plan how will we accept that there is no effect. And so this is planification, for example, sample size estimation for other kind of analysis. But I think this is something that could be considered in future, maybe in future studies. Okay, I plan my sample size for how will I confirm that there is an effect, and how can I have a sufficient sample size to confirm that there is no effect, and not just reject, not just accept H1, but also be able to accept H0.
And it's a good point.
Sorry to interrupt. I have just looked at the, realized that do you and Mehmet, I apologize if I pronounced your names completely wrong, and I just want to say hi and thanks so much. Your article is so interesting, but it fried my brain a little bit. It took me a long time to go through, and I had to Google a lot of things that I felt pretty stupid reading it, because I realized there's a lot of key terms that I struggled with, but thank you. It's a fantastic article. Sorry to interrupt on that.
I mean, that's totally okay. Like, don't. I would feel bad if you would feel that way, because it was like a philosophically heavy paper, I would say. Yet, like, it was not maybe meant for any practitioner who has like no familiarity with any philosophical terms. Like, we tried to make it more accessible with revisions, but I still am aware that it is a heavy text, so please don't feel that way.
And apologies, I didn't mean to say it was, I got it. It just, it was really useful to put words on terms that are sometimes I'm peripherally aware of, but didn't know what the specific term. So I was jotting down things that would be very useful. So it's not that it wasn't readable, it completely was readable. It just challenged me. Sorry, that's off the point. I had a question in terms of, Cyril, I think kind of following on what you were saying there. Sometimes I feel like in our discipline, and again, I'm probably speaking from the work that I work in, I can't apply to everyone, obviously everyone's in different fields. I feel like we almost need to go back a step, because sometimes the core hypothesis or the core theory is not so well defined, meaning it's very, very difficult to even get to the auxiliaries. And I wonder if that's, is that something that you guys find in your own work, in your own research areas, or is it me?
Yeah, it's definitely an important problem, at least in the area of exercise psychology. In each area, I mean, if we work on emotions and there are often problems with definitions of concepts that are too vague and which are not easy to operationalize. Yeah, definitely.
Yes, I think one of the best examples of what you just said, Aina and Emir, is it's from ego depletion. Like it's an exhaustion of resources. Okay, what is a resource? What is a resource? How do we operationalize? Is it glucose? Is it something you feel? Is it something we don't absolutely know? There is absolutely nothing on the original theory that say what it is and how we could capture it, even if it's wrong. We don't know how to do it. So sometimes it's not just one. Okay, it should be another resource. Okay, but what it is, so we can imagine some different operationalization, and it's so vague that we can't, or it's very difficult to imagine different operationalization. And I think sometimes it's the same on other fields.
Yeah. I think in response to Aina's main question here, how can the ambiguity of falsification be addressed? For me, I think topic-specific experts on each part, in terms of methodological experts, biological experts, and theory experts, is really needed in terms of I just remember sitting down with, I don't know if you guys here know Professor Roger Harris. He's retired now, but he's basically the guy that figured out we can supplement with creatine. He's essentially underpins creatine supplementation. But I remember sitting down with him and we were looking at a particular outcome, and we were trying to figure out what underpinned this outcome. As an increase in muscle buffering capacity. And he was just able to rhyme off, right, well, it can't be myoglobin because PK is this, it can't be this, so that only leaves this or this. Is it feasible to increase? Like, his knowledge of the underlying biochemistry was so strong that he was able to just rhyme off what theoretically may or may not have impacted, what theoretically was biologically plausible or not. And it was just kind of an eye-opener for me in terms of, if we can understand the biology, we can quite quickly rule in or out potential confounders, potential auxiliary, potential things that we need to consider. What's, I think what you guys spoke about is there's a potentially infinite number of auxiliary hypotheses, but if we've got the subject-specific experts, we can fairly quickly get to the ones that are likely to have an impact. So I really do think that the team is huge.
Yeah, I think that you make important points with regard to the need to work with experts in each domain or concerning each variable of interest. And so I think I'm going to continue, and that some of the points you address are also were also questioned by in the paper of Tunc and Tunc. So if I go further, so yeah, so can we address the ambiguity of falsification by using valid and reliable measures and designs? This is actually what Popper proposed, and what was the Popper answer to the problem of ambiguity of falsification. So for Popper, the solution was to make auxiliary hypotheses unproblematic by setting up studies so that there would be little reason to regard auxiliary hypotheses as part of the empirical test situations. So, for example, by using well-validated measures. And Popper, in this case, the empirical test, we are sure that it allows exclusively to confront the theoretical claim to evidence, and that it's not a test of auxiliary hypotheses. But the problem, and you talked about that, Emir, is that in the social and behavioral sciences, auxiliary hypotheses are often very problematic because theoretical concepts are often vague and loosely defined, because auxiliary hypotheses are not independently testable or difficult to experimentally isolate, and because hypotheses are covered in ambient noise, because researchers don't have full control on the environment of inquiry. So, for example, you don't have full control on the characteristics of our we are not sure that our participants have all correctly understood the instructions. We do not know every time if, for example, the luminosity of the lab or the time of the day may have a role in the results. And so we cannot control everything. So auxiliary hypotheses in social and behavioral sciences and sports sciences are often problematic. So the solution proposed by Popper, according to Tunc and Tunc, may not be applicable to our field. Another solution that has been proposed to address the ambiguity of falsification is to conduct replication studies, because on the one hand, closed replications are supposed to test auxiliary hypotheses such as the reliability of instruments. And on the other hand, conceptual applications are supposed to test hypotheses concerning the operationalization of variables. So we may think in the first slide that at first that replication studies can address ambiguity of falsification. So just to make sure everybody has the same definition. So we define here close replications when they test the original study in conditions that are as close as possible to the conditions of the initial study. And conceptual replications try to replicate the results using different contexts. So for example, a different operationalization of variables, a different design, a different population. Okay. So, okay. Do you have any idea of what is the problem with replication studies and why they or why one isolated study cannot address the ambiguity of falsification problem? I don't know if you have any ideas about that.
Can you repeat your question, Aina, please?
So why we may believe that replication conducting replications may help to address the ambiguity of falsification problem, but so according to Tunc and Tunc, this is not the case, and I just would like to know if any of you have any idea of why conducting replication study may not be enough to address the ambiguity of falsification. Okay, if you have no idea, I will continue, but just.
My third thought is that if you conduct only close replication, or that are also called direct replication, you are only reproducing the same study. So the operationalization may be wrong. You are just reproducing the same operationalization many times. So it doesn't help, because you just know that your construct, let's say a questionnaire that assess a construct, you just replicate the effect of this questionnaire, but this questionnaire can sucks, and so you don't have any idea regarding the theory because you have only one operationalization at a moment.
I think I feel similar in that I'm not sure of the benefit of close replications in certain cases. And again, I'm coming back to my own work, which is more biochemistry or biologically, like there's either a pathway that makes sense or not. And I feel like sometimes we focus on replication to see if we can repeat a result, but we don't focus on whether or not it's biologically plausible. And I feel like it would be more beneficial to better understand the biology and if it's plausible and if it makes sense, which I think can be tackled from a number of ways rather than just replicating. And I think that that's something that in terms of falsifying our theories, there's certain things that can be ruled in or out based on understanding, that we don't necessarily always need to jump to replicating. Some questions I think don't need to be replicated, or studies don't need to be replicated. We can base on theory. So I think replications can be useful, but we have to be very strategic, I think, about what and how we choose to replicate. I don't know if I'm going off target there.
Yeah, no, exactly. So if we, the problem of closed replications is that if we have initially valid operationalizations, then closed replications will also be invalid, the results. And the problem of conceptual replications is that they face exactly the same problem, same ambiguity of falsification problem. Because when we test, okay, if I just go back, here, so if we test in a conceptual replication our question of interest, then it is still difficult to interpret the results because we don't know if, for example, a non-corroborative finding is due to the theoretical hypothesis or to one of the auxiliary hypotheses. So it's in a conceptual replication study, we still have exactly the same ambiguity of falsification problem. Okay, so okay, so results of single replication studies also rely on isolated tests to rule out at least 3 independent hypotheses at once. So this is what I just said. So you have no other comments, I will continue by presenting the method proposed by Tunc and Tunc to address this ambiguity of falsification problem. Okay, I will present the method in an overall, in a general manner, and then I will describe it step by step. So don't be afraid of the graph here. So the method is called the systematic replications framework, and it is a replication procedure which consists in a systematically organized series of replications that function line. So it's a method based on replication, but with a very organized series of replication. And this makes the whole difference. So as I said, the authors reason that isolated replication studies face the ambiguity falsification problem. Similarly, as the initial study, they aim at replicating. And to address this problem, the solution or the position is to coordinate close and conceptual replications. And if we coordinate close and conceptual replications, then we can benefit from their advantages while controlling for their respective weaknesses. So the systematic replications framework is supposed to allow establishing a stronger connection between the theory and test, because it is supposed to help us identify what are the most problematic parts of the hypothesis under investigation, and to understand if a non-corroborative result is due to the theoretical hypothesis or to auxiliary hypothesis, and which one. Okay, so I'm going to present in more detail the systematic applications frameworks. The method consists in 6 steps. So the first step is the original study, the initial study. The second step consists in close replications of the original study, so in which we test the original predictions in conditions that are as close as possible to the initial study, with similar operationalizations, with similar research design. So that's the second step. And then the third and fourth step consist in conceptual replications, in which, okay, so in step 3, we manipulate or we change, we vary only the hypothesis to the predictor. So that's step 3. In step 4, we do a close replication of step 3. Okay. Then in step 5, we do additional conceptual replications, in which we vary only the auxiliary hypothesis related to the outcome. So for example, the operationalizations of the outcome. And the rest remain unchanged. And the step 6 consists in a close replication of this conceptual replication. So this is the way the method is organized. And so the reasoning behind these replication studies is that by varying only one set of auxiliary hypotheses at each step, while controlling by doing that, it is therefore possible to identify if the refutation of a result is due to the theoretical hypothesis or the auxiliary hypothesis. And in this latter case, it is possible to identify which auxiliary hypotheses are problematic, either those related to the predictor or to the outcome. Okay, so I think that this framework is really interesting with the ambiguity of falsification problem. However, there is one key question which is not easy to address, I think, and the paper makes the point very clearly. And this difficulty concerns the selection of hypotheses, of auxiliary hypotheses to be tested. And I think that the quality of this selection, because if auxiliary hypotheses are not correctly chosen, if you do not choose correct or valid operationalizations, then there is still the possibility of misspecification, even if we follow rigorously the steps of the systematic replications framework. And so it is a problem because only a limited number of auxiliary hypotheses can be varied, whereas the number of auxiliary hypotheses is huge. But of course, it is impossible to keep track of all auxiliary hypotheses that are altered. So yeah, I wanted to know if you have any thoughts on how we can make sure that we select correct sets of auxiliary hypotheses, correct operationalizations, correct research designs, etc. Do you have any thought about that? And yeah, and one possibility, and I wanted to know what you think about that, is to randomly select these sets of auxiliary hypotheses.
This is super difficult. My first point is before we choose good auxiliary hypothesis, I think next theory could suggest here is one or two good operationalization of our concept, and those be less. I don't answer the question because I don't know how to answer it, so I try to something else. Maybe next theory can try to propose 1, 2, 3 operationalization that could be tested in different steps of this kind of replication framework. It could be something that helps us. And no, I don't think selecting randomly is appropriate.
Yeah, I agree with Cyril. I think there's just too much, and we could end up like really being quite wasteful with resources if we're happen to randomly get a auxiliary hypothesis that is maybe less likely. Maybe there could be some kind of screening, as in you identify based on theory the auxiliary hypotheses that you feel are most likely to influence, and then maybe randomly select what order you kind of manipulate those. But I think going random is potentially not the most efficient use of resources.
Okay. Okay, and I was asking this question because it's a question that is described in the paper, and it's described because actually it is a proposition that has been made by several authors, and so Tunc and Tunc referred to this proposition by mentioning the name of okay. Let me shut down the video so that there's no connection problem. Yeah, so it's called the randomization-based approach. And so this approach considers that individual operationalization is associated with measurement error. But they consider that if we randomly select a sample of operationalizations, then this will allow to cancel out all errors that are associated with each operationalization taken individually. So it's an approach that has been proposed, and as you mentioned, this approach is problematic because what is problematic mainly is the philosophy which is behind this approach, because it is based on the aim of collecting conforming evidence and verifying the generalizability of findings, which may lead researchers to believe that results confirm that theory, which is not in line with Popper's approach, falsification approach, which considers that it is impossible to draw such conclusion to confirm a theory, no matter how big your sample of operationalizations is. So it's mainly the philosophy that is behind these approaches that is not in line with the falsification principle.
Okay,
and,
so I have a question.
Yeah.
I have a question, Aina, because I'm not sure to understand, but if I give an example of this, how can I do it in real life, real lab context? For example, I can select an auxiliary hypothesis. So let's say that I want to operationalize one theoretical construct with one questionnaire, for example, one construct. Let's say I will choose, for example, 5 questionnaires that could match, and then I pick one randomly. Is it, or did I misunderstood something?
Yeah, I think so. What I understand from the article, and Duygu and Mehmet do not hesitate to interrupt if it's not correct, but what I understand of the paper is that when operationalizations derive are based on the theory, this can lead to this problem of not being in line with the falsification principle, because when we try to find operationalizations of one construct based on the theory of interest, then we are not trying to find instances or variables that would refute our hypothesis. So that's what I understand from the approach.
I think we agree with this interpretation, but there is another problem that I want to emphasize here, which is to define the population that you derive the sample of operationalizations from. So actually, defining this population is impossible. You can only end up with a population, so to speak, so-called population, that is very heavily theory-driven. So let's say you have a theory A. It is impossible for you to define a population without actually using all these theories, hidden assumptions as your guidance in defining this population. And we have in social sciences usually many contending theories which have many different hidden assumptions about which auxiliary hypothesis should be crucial for testing situation. Then you end up with very different populations that you derive the sample from, and you cannot really escape from this theory drivenness in terms of defining the whole population of auxiliary hypotheses. So this is why we actually, and there is also a time dependence aspect if you think about it. For example, we always develop some new measures, some new measurement technologies, and at time 1, for example, we have limited, when you compare it to time 2, limited abilities to define the whole population that you can derive your sample from. Then you add, for example, another measure at time 2, then the whole picture might change. For example, the population. I mean, if you think this in terms of, for example, the history of science. For example, the population in astrology, for example, the population that you can define before the invention of telescopes are very different than the invention of telescopes. So these two problems, like the time dependence and theory dependence in terms of defining the population, really makes it impossible for you to use this generalization-based approaches effectively. Because all the merit of this randomization, the effectiveness of this randomization-based solutions always dependent on your ability to define the population, because you use the randomization strategy to select a representative sample. If you define the population mistakenly, then your sample cannot really represent the population that you have in your mind, that you want to test.
Okay.
I can maybe add just one sentence summary of what I've understood from, I mean, what you said as a non-technical person myself. I mean, for example, you gave the example of, let's say, like we have 5 measures of the construct, let's say 5 questionnaires, right? Those 5 questionnaires, or maybe 4 of them, might derive from the same theory. Then you are like repeating the possible biases of the theory in all those measures. Actually, you are not controlling for certain kinds of error. You're just having the same kinds of error in all your measurements. And coming to time dependence, let's say you have like the 6th questionnaire, which is much better than the all previous 5, let's say, but it's a completely different questionnaire because like our knowledge of the subject has changed, let's say. Then like why bunch together all these 6 questionnaires and how do you control error if you like do it like that? All like previous 5 questionnaires are maybe irrelevant with the invention of the 6th.
Or you can discover a 7th measure that is behavior or psychophysiological responses which actually have a higher validity than the prior 6. Then why you bundle all the 7 together and try to generalize something out of this population? It doesn't really make sense.
Yeah, I think if I'm understanding well, what keeps jumping into my head in these kind of things is like we've got X number of questionnaires that represent what we want. Assumably, you're going to pick what you believe is the best one the first time. So I'm not really sure then what's the benefit of repeating with other ones that you've already decided are not as informative as the one that you actually picked in the first place.
Exactly. I mean, conducting a conceptual replication might make sense only if you want to try the auxiliary assumption that you vary between the study 1 and study 2 using different operationalizations. If you already are sure that you use the most valid measure available for operationalizing something that you want to test, then there is no point actually in, I mean, you end up with the solution offered by the popper and you don't really need to use SRF anymore. But if you are not sure, I mean, and this is, I think, the case social psychology usually, then you follow this route of, trying to triangulate somehow the results using different kind of operationalizations. Of course, for example, we can be sure that for certain questions, for example, self-report measures are not really that good. I mean, if you have some psychophysiological or other biochemical markers that you can use for measuring the exact same variable, then why I mean bundling self-report measures with the other better measures? I think this is the shortcoming of randomization-based approaches in a nutshell.
And one other problem, not different from the randomization based approach, but another problem is that we tend to use in our studies always the same or the same experimental manipulations, and I think that it limits the generalizability of the findings. And one reason that we tend to use similar operationalizations is that we know that when we are going to try to publish the study, then we need to convince the editor and reviewers that our measures have been used already, that they have been validated, and this leads us to use or tend to use always the same operationalizations, which not may be good to generalization of finding, I think. Okay, so let me continue. We have seen the problems, the limitations of randomization-based approaches. And so the idea behind the systematic replications framework is different. And in this method, the variation of operationalizations is not a random procedure. It includes only the auxiliary hypotheses that are expected to have a meaningful impact on the results, and that can provide the most plausible alternative explanations associated with auxiliary hypotheses. So in this method, confirmatory results are interpreted only as a further corroboration and not as a confirmation. And the door is never closed for possible alternative explanations. And I think that it's a key element of this method to always look for plausible alternative explanations associated with our auxiliary hypothesis. And so if I continue, another point which is made in the article concerns the ability of the systematic replications framework to limit misspecification. So to define specification, we say that a theoretical model that it is perfectly specified only when the theoretical hypothesis can be held to account for the test results. And so most of the time, as we have already said, in social and behavioral sciences, it is very difficult to perfectly specify a theoretical model. There are two possible sources of misspecification. First, one or more elements in the auxiliary hypothesis can be false or invalid when we use invalid operationalizations or experimental manipulations. And some auxiliary hypotheses can be mistakenly considered as non-influential, whereas they have an influence, a true influence. And the systematic replications framework proposes to limit misspecification by probing these two sources of misspecification. And more particularly, the framework includes 3 probes. The first one is a stability probe, which contends that the theoretical model should be associated with relatively stable observations. And this can be verified by conducting closed replications as proposed in the framework. The second probe is the boundary conditions probe, which stipulates that the boundary conditions of a theory defined by the auxiliary hypothesis should not be too limiting. And so with it regard, conceptual replications are useful because they can delimit the application of the theoretical hypothesis by testing it using different operationalizations and different contexts. And the last probe, which I think is very, very interesting, is the contending theories probe, which stipulates or which emphasizes the necessity to examine probable alternative explanations that are associated with different auxiliary can be done by comparing the theoretical model put on by one theory to the theoretical models of the contending theories. And the paper mentions one possibility to do that by conducting adversarial collaborations. And I think that it is a very promising approach, which can help us to focus on plausible alternative explanations rather than trying to confirm our hypothesis. And yeah, so the question is, what do you think? What are your thoughts about the framework, its application in kinesiology and sports sciences? Have any of you already been involved in adversarial collaborations? I know that it is increasingly used in social psychology, at least. I don't know, in sports sciences. So yeah, what are your thoughts about that?
I love the idea of the adversarial collaborations, and I think in my discipline it's something we need a lot more. We all tend to group with those who echo chambers, stick with the people that support our viewpoint and reinforce it. Sorry, Aina, before we address that last question, may I ask a question that I really struggle with in my own head? Is something I really struggle with is differentiating between my primary hypothesis, my auxiliary hypotheses, and the boundary conditions, and where one becomes another. So for example, the example that you gave was, does social presence impact basketball performance, looking at free throw, whatever it is. The first thing I would assume is that that's going to be very much dependent on the individual. Some people will respond well to the crowd, some people will freak out. It might also depend on the stage of the game. Is it an important game? Who's in that crowd? Is it close family or friends, or is it random strangers? There's so many things that might impact that. And I'm not sure, would they be defined as the boundary conditions? Let's just say the psychological state of the individual on that particular day may impact whether or not they respond well or not to say the crowd. Is that an entirely separate question? Is that an auxiliary? Is that something we need? I struggle to understand where I go from an entirely separate question to what's the boundary condition. Sorry, I don't know if I'm making sense now.
Yeah, I would say that it depends on the because, for example, when you look at the effect of the social presence on a sport performance, the main, one of the dominant theoretical framework is the domain of social facilitation and inhibition effects, which consider that social presence may facilitate performance if you master a task, if you are an expert, and it will debilitate performance if you are not an expert. So I think that if this proposition is defined in the theory, then it is not a boundary condition to test if expertise moderates the effect, because it's something we know, which has been tested a lot of times, and which is included in the theory. So that would be my answer. I don't know if I'm correct, but yeah. But yeah, I think it's difficult to clearly see the delimitation of boundary conditions.
It just made me think about something. When you read a paper about a theory, it's always, hey, here is how my theory works, and here is, if you do A, then B, and so here is the theory. But there is never sentences citing precisely, hey, this is the situation where my theory is wrong, and this is how it doesn't. If this is true, it doesn't work, and this is not my theory anymore. And so maybe I don't know if it joins with what you just said with the boundary condition, but it could be a way to place some boundary condition. This is our theory. This is the condition where it works, and we think that if this is not respected, the theory is wrong. And so it's thus the falsification is clearer, I think, for the researchers.
Exactly, I agree completely with both of interpretations. I would say personally that some auxiliary hypotheses are more central for the theoretical hypotheses than others. So not every auxiliary hypothesis that you can come up with is at the same centrality for the theory to be tested. So I think for some auxiliary hypotheses that are peripheral, cannot really be regarded as the critical test of the hypothesis. Then the theory can defend itself as defining these auxiliary hypotheses as boundary conditions. So in this sense, boundary conditions is a type of auxiliary hypothesis that is not really very central to the theory and is somehow falsified by evidence at some point, but then the theory still has some merit in terms of empirical content, like it shows its merit in various other tests, and the last test it fails is not really a crucial test for it, then the auxiliary hypotheses that bring about this last non-corroborating result might be regarded as a boundary condition for the theory. So I think it's a kind of peripheral auxiliary hypotheses that are not corroborated the main hypothesis.
I always find that an interesting one. Is it often pops up in journal reviews where it's kind of like, here's my study, here's what I think it means. And then a reviewer comes back is like, but what about this? And I just kind of think, well, that's a whole other study. Knock yourself out, go crazy, test if it works in those conditions. But this is what I'm studying. It feels like, yeah, it's
exactly. I agree that there's a very subjective element to it, like which auxiliary hypotheses are central to the main hypothesis can be a subject to discussion, but not in every case. Like we can be sure that for some auxiliaries that are quite central to the hypothesis. But absolutely. I think there is a room for discussion in terms of regarding an auxiliary hypothesis, a boundary condition or a true refuter for the theory.
I mean, I guess a very simple example would be, let's say, like your theory has been tested in, let's say, England, but like theoretically, you would have like no reason to expect that it only works in England. Let's say, like you have no such specification. Then your boundaries are actually too tight than what you have expected. But if it works like in like 20 countries, but only not in China, then you might maybe treat China and some specific conditions in Chinese population, let's say, as boundary conditions, and you can say my theory survived, but not in China, then for this and this reason. I guess that would be sort of the limits on both ends.
I have another very broad question, but it's maybe going off target. So if anyone has anything else to kind of add on that, go for it.
If I just made a comment regarding your last slide, Aina, and I really enjoyed the paper you wrote, you presented this preprint, I really liked it. Maybe it's because we are actually on the paper about a theory, and when I read it, I was like, okay, I know what I have to write or not. So it helped me. But one thing is that you said about, for example, collaboration and teamwork, and when we are working in such with such a framework, if we adopt the application, the systematic replication framework, I think it's even more important to find collaborators to work with, because, for example, if for one study you need a sample size of 100 people there, and I don't say it's a limitation, it's just something you have to consider. If you need 100% one time, in this framework, you will need maybe 7 times 100%. And if you want this successful, I think it's even more important to collaborate and find other teams that want to work with you. And I think it's important to collaborate, but this framework is a great example of why we should to be able this kind of framework to work.
Yeah, exactly. When I read the paper, I found the approach very interesting because it's a way to better organize and at the same time it is very, very ambitious. So I think, as you said, that it's obligatory to conduct such a method in multi-lab studies, so with other laboratories, because there are too many studies to be conducted to complete the full steps of the method. And I particularly like the idea of adversarial collaborations, because it means that you have to work with researchers who work on different theories, who are trying to explain the same phenomenon, but with different ideas. And I think it is probably very, very interesting to try to work with these people together, people who have different ideas, and to come up with operationalizations that can help us to distinguish and to decide which one of our theories is the correct one or in what conditions. And this is a very promising approach, I think.
I think
it's the moment for your broad question, Amir.
Just to follow what Aina says, I think these kind of frameworks are so useful to help us define, and I think how closely you can follow and how much you can do is really going to depend on your research area too, like Cyril said, in terms of, sometimes I work with, like, say, training interventions and we take muscle biopsies. We have to be very selective about how we manipulate because it's such an invasive and intensive procedure. Whereas I think if you're working, say, with maybe questionnaires where you can distribute them more broadly, you have much more space to say, manipulate and vary. I suppose, okay, I'm going to struggle to frame this. We have these big questions, like the example today, does social presence impact performance, or the examples you gave. From a philosophical perspective, do you guys believe that we should approach that? Are these just abstract theoretical constructs, or do you believe it's actually possible to get to a yes, no answer? Or, like, what are we actually trying to do here? Is it possible to get to truth and an answer for these big questions? Or should we just view these big questions as broad theoretical constructs that will never actually answer yes or no, but will shape our thoughts?
If I just answer with Popper's words, you never say yes, you just say it's not false for the moment, so let's go with it.
We'll roll with it for now.
Yeah, Popper is not usually known for this aspect of his, but I guess it's quite prominent. Popper is quite economical in terms of methodology, really. The problem is, yeah, to define exactly when to say no, because if you are conducting like hypothesis tests that are like low in informational value, then you really learn very little, close to none from your test actually. And you might as well not conduct the test because you're like just creating more uncertainty for the field. Of course, like science, it is in the very nature of science that you cannot never acquire a yes from data, from phenomena. It's like in mathematics, philosophy, or very formal disciplines only, you never have a yes. But it is a no is valuable, but you should have a manageable level of uncertainty. You should be able to tell with like acceptable levels of error that this is a no, and this is what we are trying to get at.
I think what should we be able to do is to judge the relative merit of alternative explanations that we are testing. An example from my own field is the relationship between violent video gaming and violent behavior. So we are actually investigating this question for 3 decades maybe. And you know what? There are 3 logical possibilities. Like it positively affects the violent behavior. It's negatively affects the violent behavior. It doesn't have any effect. And all these 3 logical possibilities have some kind of corroboration in the literature, and they are still, I mean, vying for survival. It is, I think, so preposterous, so unacceptable. It is, I mean, then why are we conducting all these studies? Why are we, devoting
so
all these resources to these questions? Of course, at the end, we might not end up with a clear-cut yes or no question, but I think at some certain time point, we should be able to say that, yes, this option has more support than the other options.
Oh, I will push back on that now. I'll push back on that because, so recently I've started working more with individual response and individual variation. Is it not acceptable to say that all 3 scenarios are true, depending on the individual? So you are going to have some people who violent media will encourage violent behaviors, some people that will just not be affected, and some people who will actually put them off. Is the real question not that, okay, with 3 scenarios, could we potentially accept that all 3 are true? But the real question that we have to answer is what characteristics indicate who goes in each.
Exactly. I mean, that would have been the perfect answer to the question whether there is a relationship between violent video games and aggressive behavior in children. That would have, I mean, the example that you give, for example, if we are able to explain the moderating factors that brings about these different options, that would have been the perfect answer. And actually, the framework that we are suggesting is, I think, a great way to establish that kind of a detailed explanation especially through boundary conditions probes and contending theories probes.
And yeah, I guess like science usually begins with that kind of question, as you call it, like maybe the big question. Usually you begin like that, but that doesn't have to be your like final question that you have an answer, because like usually you start with such a question and then you end up saying, if A and B is the case, the first option, if C and D is the case, some version of the second option, and that means you have learned from the process, actually.
But the examples that we gave in the paper are all on the opposite side. Like they are still struggling with, you know, whether for the whole population, violent video gaming, for example, has a negative effect on aggressive behavior or something like that. They haven't really moved away from this point very much far in these 3 decades. And yeah, this is, I think, a waste of resources. I mean, and this is probably because they do not really organize their studies or, you know, coordinate their efforts quite well. They are just trying to establish what they think might be true through individual studies, isolated individual studies, and
their pet studies, actually. Like
their pet studies, and with very low power, and also, you know, single operationalizations explaining everything.
Maybe biased measures like under that.
Exactly, and this is, I think, why we end up with such a mess.
I think something that is that I'm kind of coming to more and more is that maybe just embrace uncertainty and focus on effort on figuring out what underpins or what's the biggest driver of that uncertainty, rather than trying to maybe do the impossible, which is to create certainty from uncertainty. And it just kind of feels like it would be more fun research if we could all just agree that, well, actually, it's all true in some situation. Now let's figure out those situations. But it's harder to tweak that.
Yeah, but like, I guess it's the main point of the classical paper from Platt. I guess we also cited like the strong inference paper, like systematic collective scientific effort involving many people, many labs, which like try to figure out all these branches, like, all these like options that branch out from one single theoretical question, like eliminating alternatives, like having more or less definitive answers on very low level, let's say less abstract questions, like these measures like work together in creating this effect, these measures don't work together in creating this effect, and so on, but having like more or less definitive answers on these very low level options, and achieving this like by collectivizing, like, or organizing your resources and time really.
Aina, apologies, we've probably gone drifted off from your last questions.
Yeah, I was wondering when listening to the discussion, and it's question maybe more to you and Mehmet, but to everyone else. So, what do you think about meta-analysis? Do you think it's another solution? It's different than the framework you propose, but it's also a way to to see if if there is a true effect based on a number of studies that use operationalizations that are different, research designs that are different. So I was wondering, what do you think about meta-analysis and if they can address?
Maybe we should add something to the paper as well about meta-analysis. I really think meta-analysis is a great tool for answering some certain questions. But I think most important shortcoming of meta-analysis or another statistical procedural tool is that garbage in, garbage out problem. So if the studies that you included in your meta-analysis are garbage, then your results will be garbage as well. So I would say that SRF is actually a way to establish a literature where you can use in a meta-analysis and reach trustworthy results, so to speak. So it is a way to decrease garbage in this sense. And I think only after such an collective effort that we envisioned in SRF that you can actually trust the results of a meta-analysis. Or you should have another way to validate your choices of studies to include in your meta-analysis. And I think it is really quite difficult to do it in a very noisy literature. So if you especially are in a noisy literature, I think SRF would then work as a way to clear out the mess. But I don't think they. I mean SRF and meta-analysis cannot be used together. I think it would be the best if we somehow combine the powers of two together in a way.
Mm-hmm. Okay.
But as it stands, I don't really believe meta-analysis to be a tool for resolving disputes, especially in social psychology. For example, I mean, if I am to follow my earlier example about violent video gaming and aggressive behavior in children, people are publishing contending meta-analysis for every 2 years in my field. Like one meta-analysis shows a clear effect, one meta-analysis shows no effect, another shows a negative.
So the exact same situation occurs at the higher level, at the meta-analysis level.
Exactly. I mean, this shows actually that there are a huge wiggling room if you conduct a meta-analysis in a noisy literature, which shows that meta-analysis itself cannot really be used as a way to resolve these kind of disputes.
So increase the quality of literature.
Yeah, but if you are operating in a less cluttered literature, I think meta-analysis is a great tool for summarizing or aggregating the results through all these studies that you find in the literature.
Yeah. I think I'm very biased because I work a lot with meta-analysis, but I think that as with any design, they're completely open to bias, to manipulation. The garbage in, garbage out is very relevant. I think that one of the power of a meta-analysis can lie more in, say, its certainty and certainty assessments, for example, like GRADE is used in health-related research. And I think in terms of exposing the weaknesses can sometimes be an informing ongoing research rather than trying to come to a definitive answer can sometimes be maybe the strength of a meta-analysis, because it would be crazy to say that, oh, they're the solution, but I definitely think they're a tool to sort through how things can be done. But I think sometimes we use them, we kind of assign them more value than they warrant. But again, you can have a great one, you can have a crap one, same as with most studies. But yeah. So many thoughts here. Guys, would you be willing to do a talk at some stage on your work for the STORK seminars? I think
of course, we would be honored.
We arrange kind of monthly discussions, and actually one of our last topics was with, I'm aware you guys collaborate with Daniel Atkins. He did a debate on kind of for and against p-values, and your paper was quoted in there. And yeah, there's just so much to unpick here that journal clubs, we always start unraveling things and then it always goes further and further. But it would be great if you guys were willing to participate in some of our sessions, because I think philosophy and underlying philosophy and conceptual frameworks is maybe something that's not widely taught in our, say, undergrad and degrees, and it's sometimes I feel like we're talking about the same things, we just don't have the terminology to put in it to describe what we are trying to say, or sorry, well, I don't anyway.
It is also like hard to dig out that kind of maybe not information, but let's say conceptual frameworks from philosophical literature itself. Like, as scientists, I mean, philosophical papers are usually quite out of touch. They tend to be quite out of touch with scientific practice, really. So like we actually think that it's quite valuable to work together as a philosopher and a scientist on these problems, and because then we immediately see during the writing phase what we understand from each other's like sort of perspectives, what we don't understand, what we like feel like can admit more elaboration and so on. So it really helps to bring these fields together. We already like to do that by working together.
Yeah, I was curious. Are you guys married? I was wondering the Tunc and Tunc. I was wondering are they is that coincidence or not? No, obviously not. But yeah, I think definitely bringing disciplines and perspectives together has so much scope to kind of collectively move things forward.
Yeah, interdisciplinarity is hard. Like I had other experiences as well, and being married helps. I don't recommend that to like all interdisciplinary collaborations, but if it's possible, it helps. You have lots of time to discuss things, and you have to agree at some point. You cannot get a divorce over a paper, right?
Well, I can see this as being kind of like the violent media and aggressive behavior. There's probably some situations that affect us positive, some situations negative. There's probably a lot of parameters to consider here.
Sure. Like we have many papers that will come that will follow this one actually, like follow-up papers. Nice. So we would definitely love to remain in touch, maybe with respect to this paper, but also like about upcoming projects we are working on, like trying to establish a better notion of how to conduct good hypothesis tests, like let's say have like to establish this as a general project. But we also have another follow-up project about replications. What is a replication study? What kind of replication studies can there be, and so on. So we will unpack many different discussions that were like very compressed in this paper.
Nice. Yeah, I think as soon as it starts on one, there's just so much to unpack in all of this. But guys, I'm kind of aware we're running out of time. Aina, sorry, we kind of abandoned the end of. Oh, hello.
Yeah, sorry, my interviewer just arrived, so.
No problem. But yes, this is what I thought. I think we have discussed all the questions, and maybe next session we answer anything. So I think we can stop here for this journal club. And I would like to thank you, Aina, very much for this insightful presentation, and thank you, Tunc and Tunc, for your article, because it's great, and I think it will help think forward. So yes, thank you everyone for this. And
we thank you very much for the presentation. Really, like, we couldn't have presented it better ourselves. I really love the slides.
So the whole discussion is recorded and it will be uploaded in YouTube soon. So if you want to share it at the moment to show this discussion, feel free. Yes. See you soon, everybody.
I will stop the recording here now. Aina, thank you so much.